Okay, question 3 of homework 5 on radians. This time we're solving an equation in radians. Okay, so we're not using the radian formula this time, we're just solving a trig equation sort of as normal, but with the answers in radians. Okay, now this is one of the classic styles of trig equation where you've got a sine and a cos, not squared, notice, so you can't use one of the Pythagorean identities. You can't use sine squared plus cos squared equals 1. But you can use sine over cos equals tan. And to see that, if you take the cos term to the other side, okay, and then divide through by cos 3 theta, so divide both sides now by cos 3 theta. Of course, that cancels over there, and over here we've got sine 3 theta over cos 3 theta, which of course is tan 3 theta. So that's then been rearranged to give us a much simpler equation, tan 3 theta equals root 3, which we're now going to solve. Theta is between 0 and pi. Now, if theta is between 0 and pi, and we're dealing with 3 theta, we need to be conscious about what 3 theta is between. So if we multiply this through by 3, then we get 3 pi at the end. Okay, so initially we're going to try and generate values from doing inverse tan. We're going to try and generate values that are between 0 and 3 pi. Okay, so inverse tan then of root 3 in radians. Now that is pi over 3, but let's just check, see, you might not know that automatically, so let's just see what the calculator tells us. So inverse tan then of root 3, oops, syntax error, inverse tan of root 3, move the cursor and then do that. Okay, it comes up nicely as 1/3 pi, so it's presented it in a nice format for you there. Okay, and now it's at this stage, of course, that we need to generate lots of other possible values. Okay, not dividing by 3. The division by 3 there happens at the very, very, very end. Okay, I'm aware that some of you will have used a graph, some of you use cast diagram. I'm just going to use a cast diagram here, but in a minute I can do the graph version 2. Okay, so I've taken that then around from 0 to half pi to 3 over 2 pi to 2 pi, and then to 5 over 2 pi, and then around to 3 pi and stop. Okay, so that's all the angles then between 0 and 3 pi sort of ready to go. So an angle of 1/3 pi, which is 60 degrees, is about like that. 1/3 pi radians there. Okay, now that's in the all quadrant. Nice and positive, of course, so the other quadrant is going to go in as the tan quadrant in this case, which is directly or diagonally opposite there. And of course the angles are always made with the horizontal when you do this diagram, so that angle there comes down from the horizontal there. Right, so then we can start going around. So we've got the 1/3 pi listed already. Keep going around, you get to pi, then add 1/3 pi. So you've got 1 pi plus 1/3 pi, 1 and 1/3, which is 4/3. So that's 4/3 pi there. Okay, keep going round, you get to 2 pi, then you add another pi. 2 plus 1/3 is 7/3. So 7/3 pi. Keep going round and you hit 3 pi and therefore we stop. Okay, so I don't need that remaining space there. Okay, had you used the graph version instead, let's just quickly see what that would have looked like, starting at 0. Okay, so that's half pi there, pi, 3 over 2 pi, 2 pi, 5 over 2 pi, and 3 pi. Sorry, a bit skew there for you. 1/3 pi is about there. go up to the graph and then across and down, and here you can see then, so that distance there is your 1/3 pi. Add that onto your pi. Pi plus 1/3 pi is 4/3 pi. And similarly over here, 2 pi plus that extra distance of 1/3 pi, 2 1/3 pi, which is 7/3 pi. So your two methods then for doing that. Okay, final step then is to divide 3 by 3 here. So if 3 theta equals 1/3 pi, 4/3 pi, and 7/3 pi, then 1 theta equals each of these divided by 3, so that's 1/9 pi, 4/9 pi, and 7/9 pi. And they're all between 0 and pi, which was the original domain given in the question. So we were okay with that. Okay, so they're all there. Okay, that's the end of question 3.